Aloha and welcome. In this chapter, we're going to be talking about cloud security. We're going to start off in this video with an overview of cloud computing and deployment models. So what is cloud computing? You've probably heard of the cloud. Everyone's talking about the cloud, the cloud, the cloud, the cloud. What is the cloud? Well, the cloud is not some mystical place that everything goes or, it's the source of all our programs or whatever else we're using. The cloud is simply somebody else's servers. It's somebody else's server and, data infrastructure that exists somewhere else. So we get to it through the internet. So let's go ahead and dig into that. So cloud computing, it's the computing model where IT resources are offered on demand over the internet. So cloud service provider or cloud provider is an entity that offers cloud computing. There's examples of this. Microsoft has Azure, you've got GCP from Google, you've got AWS from Amazon. All of these are cloud providers. So we're going to start talking about the three cloud computing models out there. We've got infrastructure as a service, IaaS. We've got platform as a service, PaaS. We've got software as a service, SaaS or SaaS, as a lot of people call it. So when we start with infrastructure, infrastructure is a cloud computing model that offers infrastructure components on demand. Infrastructure components, that's going to include networking, storage, servers, and virtualization. Platform as a service, that's a cloud computing model that offers hardware and software tools for application development and deployment. So PaaS, as it's called, PaaS or PaaS includes networking, storage, servers, and virtualization, as well as operating system, middleware, and runtime components. So the example they give in the book is that Google App Engine is a PaaS offered by Google for developing and hosting web applications in Google managed data centers. Then lastly, we have SaaS, which is software as a service. SaaS is a computing model that offers a software application over the internet. A SaaS provider manages access to applications and data and is responsible for application security, availability, and performance. So an example of this is going to be Gmail. Gmail is a SaaS email service by Google. And lastly, we have something called anything as a service. And anything as a service, XaaS, that's a term that refers to any product, tool, or technology that's offered as a service over the internet. For example, you can have communications as a service, CaaS, cloud provider. They may offer voice over IP, VoIP, and video conferencing services over the internet. So whenever you have that whatever as a service, it's going to be XaaS, where you fill in the X. And the book does a good job of explaining through a participation activity the different cloud computing models. It'll show you what's included in each IaaS and PaaS and SaaS. So it's going to show you, what's included in each of those. So do take a look at that. We have several different cloud deployment models. We've got public cloud, we've got private cloud, we've got hybrid cloud, and we've got community cloud. So the first one is the one that most people are familiar with, public cloud. And a public cloud is a cloud deployment model where the cloud infrastructure is provisioned for use by the general public. General public is me and you. So public cloud exists on the cloud provider's premises and is accessible over the internet. Like I said, we talk about the cloud, but really comes down to some other company's physical resources that are giving us this service. So public cloud is commonly offered as a pay-per-use service. AWS, GCP, which is a Google Cloud platform, and Microsoft Azure, they're all public clouds that we can use as the part of the public. The opposite of this is a private cloud. And a private cloud is a cloud deployment model where the cloud infrastructure is provisioned for exclusive use by a single organization. A private cloud may be managed and operated by the organization that owns the private cloud, or it could be managed and maintained by a third party. So private cloud may exist on an organization's on-premise infrastructure or off-premises. And often when we're talking about on-premises and off-premises, we say on-prem or off-prem. So a virtual private cloud, a VPC, is a private cloud where the cloud infrastructure resides within a public cloud. So the public cloud, which me and you use, there could actually be private clouds within there where in the vast scope of Azure or whatever, you have a little section that's privately, singled out for use as a private cloud. And those are called virtual private clouds. We have the concept of a hybrid cloud as well. And a hybrid cloud is a cloud deployment model where the cloud infrastructure from both private and public clouds are bound together by standardized or proprietary technologies. So hybrid cloud enables the sharing of data and applications between different cloud deployments. So an example of this is going to be an organization that may store sensitive client data on a private cloud and have their business intelligence application on a public cloud, and they can interface, between. So that's an example of a hybrid cloud model. And then lastly, we've got a community cloud. And a community cloud is a cloud deployment model where the cloud infrastructure is provisioned for exclusive use by organizations within common computing concerns. So common computing concern may be regulatory compliance, could be performance, could be security requirements. It can be owned, managed, and operated by the organizations in the community, or it can be managed by an external managed service provider, an MSP. So a community cloud may exist on or off an organization's premises as well. So when we're talking about the community cloud here, um, think of like government organizations that all need specific requirements like FedRAMP compliance, or they've got some type of compliance. Maybe it's a school type thing where FERPA is a big concern. You can have these that share, these communities that are bound by certain needs, whether it's compliance or whatever. Then the next thing we're going to talk about is fog and edge computing. So fog computing, also known as fog networking or fogging, it's a decentralized computing infrastructure that extends the cloud through the placement of nodes between the cloud, the other people's infrastructure, and the end devices. So a node or a fog node is a non-end device. So it's not at the end, it's somewhere in between. It's a non-end device with computing, storage, and network connectivity. So the fog node reduces the cloud latency, which is the delay in sending and receiving data to and from the cloud, by processing data near the end devices. So instead of having to send it from the end node all the way up to the cloud, you're going to have it done at a fog node somewhere nearby. So in fog computing, data is sent to the cloud only for storage and long-term analytics. Then we've got the concept of edge computing. So edge computing is a computing model where most of the data processing is going to be performed at the end devices themselves. So edge computing minimizes the need to send data to a node or the cloud, thereby increasing the application's responsiveness. It's also going to reduce the bandwidth usage, and it's going to improve the latency, which is that lag. So different computing models may be used to address an application's requirements. The example they give is a self-driving car. The self-driving car, it's going to use onboard devices to analyze real-time data for car navigation, which is considered the edge computing. But it's also going to do fog nodes. It's going to use fog nodes for low latency data exchange with nearby cars to ensure that safe driving exists, fog computing here. So fog nodes are going to send data to the cloud for long-term analytics aimed at improving the car maintenance or tracking the car usage. Cloud computing, but it's not doing all that. It's just taking the end data and sending it out. And then we have the concept of regions and availability zones. So any one of these providers, let's take Amazon AWS, for example, they divide the world up into regions. Regions are really just large areas of I guess, where they're going to have their infrastructure. And we're talking about on the global scale, we're talking about continents here. We could have regions such as, Africa or South America or North America. These are the large regions. But then you're going to have these other things called availability zones. And the availability zones are areas areas within the regions. They're smaller groups of data centers in those regions. And they're built that way. You'll have multiple ones here, and they have redundancy and disaster recovery in mind for that. So if you look at a map, you're going to see things like, okay, region is going to be North America, South America, Europe, China, Asia, Pacific, South Africa, and the Middle East. Whereas when you look at the availability zones, smaller groups of data centers within a region. So the example of AWS, they have over 80 availability zones, also known as AZs, including Ohio, North America, which is, I think, where your AWS would default to when you sign up for a free tier of membership there. You've got Rio de Janeiro, you've got Cape Town, South Africa, London in Europe, you've got Bahrain for Middle East, and you've got Beijing for China. So the different regions, they're going to offer different services in terms of performance, cost, and latency. So each region is isolated from the other regions for the fault tolerance and service stability. But each region's availability zones, those zones that are inside it, they're built with fault tolerance and disaster recovery solutions in mind. So no single data center is going to be shared between those availability zones because those are really failover points. So if one available, let's say you have a big earthquake in one area, and it knocks down the data center, you're going to have a fail safe. You're going to fail over into another one in that availability zone. So the last concept we're going to talk about here is the multi-cloud system. Multi-cloud system, it's a network architecture that integrates cloud services from multiple providers to meet diverse requirements for performance, reliability, and cost effectiveness. So multi-cloud system allows an organization to avoid vendor lock-in because one thing that happens is once you buy into a vendor and you've got all of your systems set around that one thing, if they up their prices significantly, you are married to that provider, and getting off of that would be very painful. The idea here is that if you have a multi-cloud system, that's going to allow an organization to avoid the vendor lock-in and enhance their their disaster recovery capabilities. It'll also optimize the workload deployment based on the strengths of each provider that they're using. So by distributing assets across the different clouds, multi-cloud environments can also increase the resilience against service outages and regional disruptions. But one thing to keep in mind that they don't mention in the book is if you're using multiple clouds and you're duplicating costs, it could be expensive. There's pluses and minuses. There's a lot of trade-offs involved. Disaster recovery is a very important thing. The redundancy is very important. The reliability, very important. The performance. It's just that if you're using multiple clouds, you're also incurring multiple costs. So that's something to keep in mind. So that's it for our introduction into cloud computing. Remember that we have three, maybe four different models of cloud computing. We've got infrastructure as a service. That's where they're giving you the hardware and the storage and things like the virtualization, and you're responsible for upkeeping it. So they give you, let's say, a Windows server. You can apply patches and whatever else as you need. It's your responsibility to do that. We've got platform as a service. That's where you get the whole platform for doing all your applications and things like that. Then you got software as a service where they're actually, it's a software application over the internet. Then we've got the anything as a service, the idea that you can take anything that has delivery over the internet and refer to it as X as a service, whatever you fill in the X part. We also talked about the cloud deployment models. We talked about public cloud. We talked about private cloud. We talked about hybrid clouds. We talked about community clouds. And then we went and talked about the fog computing and the edge computing, the differences in the two. And we also talked about cloud regions and availability zones. And we finished up with a quick discussion of multi-cloud system. So that's it for this section. If you have any questions, feel free to reach out and I'd be happy to help. Aloha.